Hello ladies and gentlemen, how is everybody today? In this particular video, we are going to take a look at using a distribute list. So let me just write down here, a distribute list to filter RIP routes. Now, generally speaking, a distribute list with our IGPs is going to be how we filter. So you're going to have essentially the same options in RIP, the same options in EIGRP, and we'll go through those when we get to that IGP. But essentially, the options here that you're going to pick are generally speaking going to be the same. And the biggest point here that you need to take away from this is learning essentially how to subnet. You have to understand subnetting. You have to understand, the bits and how to actually do something like a wildcard mask. You have to understand your CIDRs. If you don't, you're going to give yourself, you're going to end up giving yourself a hard time when you actually try to, filter these things out. As the old saying goes, the only one you hurt is yourself. So let's actually just take a quick look at the network setup and then we'll get this going. So we're going to have a RIP adjacency between 1, 2, and 3. No DMVPN or anything like that. We're just going to be advertising all of the prefixes here between 1, 2, and 3. We have 5 loopback addresses here on router 5. We have 3 loopback addresses here on router 3 that we're going to be concerned with. And then we're also going to play around with the multipath option that's essentially going to happen here because R1 is going to see that he can get to the same prefix going through these guys. So we'll take a look at how do we filter this guy out in multiple different directions. So let's quickly get RIP up and running. So we'll say router RIP. Version 2, no auto, network 10.0.0.0, redistribute, connected, exit, do show run section router RIP, and let's be lazy network engineers and grab this whole thing, pop this guy in here, pop this guy in here, and let's say do show IP route RIP. Okay, so we have RIP up and running, very quick, very simple. And what I want to do is on router 3, I want to prevent this prefix from coming in. So in other words, I want to have router 1 always choose router 2 because he just doesn't see this prefix in from router 3. So let's make it happen, Captain. Now, multiple ways I can do this. In other words, order I can do this. I can configure the distribute list here in RIP first and then do the ACL after. I can do the ACL. I can exit out of here. I can do the ACL, then come back in here and do the distribute list. Really doesn't matter as long as I fit both pieces together. Okay, you need both pieces for this to work. Since I'm here, and again, I'm lazy, I'm going to say distribute list 1, and I need to apply this in a direction. Well, I want to filter this prefix coming from router 3, so I'll go ahead and say out. Now, I can just hit enter here. Okay, but the problem is that what if I have a RIP adjacency? What if I have a peering between router 3 and router 5 as well? Well, if I just hit enter here, then what's going to happen is I'm going to deny that prefix from going out this way, as well as this way, as well as any other direction that I may have a RIP adjacency. And I don't want to do that. So what I can do here is I can choose the interface. If I hit the question mark here, you'll see all your interface options. What I want to do is I want to say, look, just when you go out Ethernet 01. So let's say do show run section router RIP and take a look at what happens. A lot of people make this mistake where they go in and they say, whoops, I hit enter and I forgot that I wanted to put the interface, and they go back in afterward and they pop in the interface, but they don't realize that this command here still stays there. So they're going to basically filter this out twice and they spend 10 minutes trying to figure out why. So point for you to take home when you're doing something on your network, make sure that you verify as you go before you call your boss and say, yep, everything's back up, and it's down 2 hours later because you didn't verify. So make sure that you understand exactly what commands are going to stay and not. Make sure you verify and check. It's okay to forget this. It's not okay to not look and then move on for 20 minutes. So do show run section RIP, and we should be filtering. So let's say do clear IP route star, do show IP route RIP, and that did not work. Why? Because we forgot the access list. Here we go. Access list 1, and we'll say, what do we want to do? We want to deny, right? So I'm going to say deny 10.24.35.0. Now, in the newer versions of code, which is great, you can go ahead and enter the CIDR or the wildcard bits. I recommend you understand both. I'm going to do both here. So I'm going to say /24. We'll start with that. Remember, though, that I'm going to have an issue. So let's say do clear IP route star, do show IP route RIP. What just happened? Notice my next hops. My next hops are all from router 2. Why? Well, because the access list is going to have a deny any at the end of this, right? I need to add a permit everything else because remember, there is going to be an invisible, the implicit null as we call it. It's an invisible deny everything at the end of your ACL. Whenever you start an ACL with the word deny, you have to end it with the word permit. Okay, always remember that. Okay, and actually just to prove well, actually it won't work here, but we'll prove it in another point. Let's go over to router 1, do clear IP route star, do show IP route RIP, and what we should see is all of the prefixes being advertised from router 3 come back, but the one prefix we didn't want to come back is, sure enough, now gone, and that's what we wanted, okay? So now let's mess around with some other prefixes here. Let's say do show IP interface brief E assigned, and I want to mess around with these 6 prefixes here that we have. Notice how we have 3 odd prefixes, we have 3 even prefixes. We have 246 and 135. That's going to come into play in just 1 minute. So suppose that I tell you, look, I want you to just advertise 1, 2, and 3. I don't want you to advertise 4, 5, and 6. Okay, just 1, 2, and 3. This is where understanding the wildcard bits would come into play and understand how to subnet. Let me show you what I mean. So I want to advertise essentially just that subnet of prefixes here. Now, by the way, in your case, when you're subnetting, you're probably not going to have /32s here. These are all /32s. In your case, you're probably going to be dealing with the 3rd octet here. So this may be /24s. You may have other subnets within here that you're going to deal with. So be careful of that. I'm dealing with this octet, but you can apply the same principle to any one of these as you're being required to subnet or filter in your environment. So in my case here, I just want to advertise 1, 2, and 3. So what I'm going to do, I'm going to say access list 1, I'm going to say permit because I want to advertise these, and I'm going to say 192.168.2.0, and the reverse mask that I'm going to put in is a 3. Okay, now in theory here, we should see only 1, 2, 3 because it's going to essentially 0, 1, 2, and 3. So let's see what happens. Router RIP, let's say distribute list 1 out, and let's actually pick the interface because we don't want to affect any other RIP adjacency. Maybe going down to the switch or going down to router 4, we have a RIP adjacency and we want to continue to advertise everything. Now you can see here that we have all 6 prefixes coming in from router 2. Let's clear our routing table and let's take a look. And you can see now that we don't have all 6 prefixes, we only have 3. Okay, and this subnet skill is going to go with essentially whatever you want, right? So let's say I had 8 prefixes that I wanted to advertise. So let's actually modify this and see what happens. What I would do is I would go in here and I would put a 7. Okay, and what this would do is this would say, look, advertise 8 prefixes. So if I went to loopback 9, which let's actually do that. Let's say interface loopback 7, 192.168.2.7. We'll make this a /32. Give me 1 minute to create all these. It will not take too long. So we'll say loopback 8. We'll make this guy an 8. And let's do 9. And let's go and make this a 9. What we should see in theory here, let's say do show IP interface brief E assigned. What we should see in theory is we should see that we don't advertise the last prefixes. Let's say do clear IP route star, do show IP route RIP. And you can see that we advertise all the way up to 7 because we're advertising, we're going to basically stop at 8. We're stopping at that subnet boundary, if you will. Okay, so that's how you can manipulate using this wildcard mask, okay, and it makes your life a little bit easier, okay? Now, what I want to do is I want to actually remove this, and I want to say, Mr. Student over there, Mr. Watcher, I want you to only advertise the even prefixes, okay? So only, let's say that we're in a load balance scenario where we have our device here, our network here, and I want to say, you know what? I have 2 ways to get back to my core switch. 2 hops to get back to the core switch. And what I want to do is I want to cause traffic, let's say for the odds to go over router 3 and maybe for the evens to go over router 2. So that way, no matter what subnets we ever add, all the evens will always go this way and all of the odds will always go this way. Okay, I'm going to show you how to filter that. We're not set up for this, but I'm going to show you how to essentially perform that filter. But this is a use case, scenario where you might, want to say, look, I'm going to send evens this way and odds this way. You could also split the subnet block. Let's say you had a /24. You could advertise half this way and half this way. There's multiple ways you can do this. I'm just giving you a use case for the odds versus the evens. So let's actually just create that ACL and show you what it looks like. We're going to leave the distribute list here, do show run section, router RIP. We're going to leave this here because we're still going to call the ACL access list 1. So we'll say access list 1, and I'm going to say permit. I have a caps lock key on? I think I do. There we go. 192.168.2, and what's important here is the octet that you're going to perform the filtering on. So in our case, we're going to say, look, I want to perform filtering based on this 4th octet. Well, you might want to perform it based on the 3rd octet and say, look, we have multiple subnets, it's 1, 2, 5, whatever, blah, blah, blah. You would just basically perform the opposite reverse mask. You would just put the value in another octet. That's all it really is. So we want to say, I want to only advertise the even subnets down to router 1. So that octet is going to be an even number. And then the wildcard mask that I'm going to apply here is going to be a 254. And that odd number, or that even number, is going to match the octet of where I'm going to put that 254. So let's go ahead and let's go to router 1. We'll say do clear IP route. We'll say star, do show IP route RIP, and you can see we have 2468, right? So here now RIP is only going to send from router 2. It's only going to send the even prefixes, but we can easily make that odd. So we'll say no access list 1. Let's make this odd. All we would do is the same exact thing, except this number here is going to be an odd number. So that subnet field, that octet you want to filter on, would either be an odd number or an even number, okay? And then your reverse mask is a 254. So let's go into router 1. Let's say do clear IP route star, and then say do show IP route RIP, and we should see 13579. So now we have all the odd numbered prefixes that router 2 is advertising. And again, maybe maybe your network is set up differently. We're just messing around here between router 1 and 2, but you can definitely split this up. Now the other thing we can do is we can use a named ACL. So what if I want to say, hit the wrong key there. What if I want to use a named ACL and I want to say, look, I just want to prevent all these 192.168.2 prefixes from ever coming in. I don't care who they come in from. I just want to block them all. Let's say IP access list. And what I want to do is I'm going to go ahead and say standard. Let me actually question mark my way through this to show you guys. So I would say standard here, and then I'm going to give it a name. Now I could give it a number, but generally what I like to do is I like to give it a name. And I'm going to be honest here, and I hope you guys agree. As you guys get more experience, the last thing you want to do is walk into an environment and see, ACL. You want to see something like this. You see ACL 10, 12, 13, 87, 92, 4, you see all these different ACLs, and it would be in a different order. I'm just randomly, numbering these. And, you sit there and you look at this, and these guys can have, 25 lines here, 37 lines here, 12 lines here, and you're like, what are all these ACLs doing? And as a network engineer, you have no idea. You've been called into the environment, and all these guys are, it's a network down emergency, and you're spending 45 minutes trying to figure out, what they're filtering, what's going on. Is that part of the problem, why they can't reach, a particular prefix? Did they botch something? Generally speaking, in production, I use named ACLs or I use named prefix lists because I can actually label what they're doing. So when Joe comes in after me and says, what in the world did JP do? He can say, oh, well, he's got a RIP filter, or he's got an EIGRP filter, or he's got a whatever, right? It makes sense. He's got a route map that changes the BGP weight because the name of the route map is, set weight or something like that. Anyway. So here what I'm going to do is I'm going to give this a sequence number. And I can give it any sequence number I want. The network world is kind of programmed the old timers like me to say sequence 5, 10, 15. So that's what I'm going to do. But you could easily say 1, 2, 3, whatever you want. It doesn't really matter. I'm going to say sequence 5, and I'm going to say deny 192.168.2.0. And in this case, I need to put in the wildcard mask. So what I need to do is I need to say 0.0.0.255 because I'm going to block the /24 block. So in a /24, the mask would normally be this, right? The reverse mask is this. Okay, so this is the normal mask. This would be the reverse mask. A concept you guys really have to understand when you're creating ACLs. Now remember that at the end of every single ACL, there is a deny everything, right? So I'm starting with a deny. What do I need to do? I need to add a permit. So let's say do show run section access. So here's our access list. What I'm going to do is I'm going to go ahead and apply this in RIP. So we're going to say do show run section RIP. Let's go ahead and get in here. We'll say distribute list. We're going to say name. So we're going to pop in the name here. So we'll say RIP filter. And what direction do I want to apply this? I want to say in, but I don't want to apply this on every interface. I just want to apply this on my E00. Now I could hit enter here. Really doesn't matter. In this case, the only direction that I'm receiving these addresses in, the 192 2 prefixes, these guys, I'm only receiving these in from router 2, so I could have just hit enter, but I don't want to. Do clear IP route star. I like more control. Do show IP route RIP, and we see all of the 2 prefixes essentially disappeared. Okay, so you guys have to understand how to do this. All right, so let's actually remove this. We'll say do show run section RIP. And let's get into our RIP process, and let's remove our distribute list. Let's go over to router 2. Let's just clean this up a little bit. Let's say no access list 1, do show run section RIP. Let's reset, because when we reset, we get more prefixes to actually filter and play around with. So let's remove all of this. Let's go to 3, no access list 1, and let's say do show run section RIP. And let's remove everything. And I think did we remove the ACL over here? Neg. Okay, so let's get that out of here. Do clear IP route star. Do show IP route RIP. We should have everything back and everything's kosher and hunky-dory. Cool. Now, another thing I want to show you is that you can do this with an extended ACL. And with an extended ACL, what's interesting is that the source, let me just note this up here. So the source is going to become where this comes from. Okay, so in our case, if I want to filter using an extended ACL, a prefix that's coming from router 2, the source in my extended ACL would be the IP address of router 2. Okay, the destination of that extended ACL would equal the prefix that I'm filtering, either allowing or denying, right? So this is how we would use that extended ACL here. I would say, look, I want to deny this prefix, but only when it comes from this specific source, okay? So let's actually mess around there. Let's see what we can come up with. So what I'm going to do is I'm going to block this prefix, but only when it comes from router 2. So let's say IP access list, and I'm going to say 101. Every time I say 101, I have Arnold's voice in my head that says, I'm a T101. Not that you care. So we're going to say access list, oops, sorry. Wrong command here. Access list 101, and what I'm going to do is I'm going to say deny, because I want to deny it from that particular source. So I'm going to say deny, and what's the source? So we'll say host 10.2 or 10.1.2.2. So this is the source. I'm going to say, look, deny this IP from this source, and then what I need to do is add the destination. So what am I blocking from this particular host? And I'm going to say 10.24.35.0, and I need to enter those wildcard bits. So I'm going to say 0.0.0.255. Now I'm going to say router RIP, and we'll say distribute list, and I'm going to say 101 in, and I don't need to apply an interface because I've said, look, I want you to deny it from this particular host. So let's see what happens. Let's say do clear IP route star. Let's say do show IP route RIP. And we killed ourselves. Let's say do show run section access. What did we do here? What did we do? We said, I want you to deny, but we didn't add the permit anything else, right? So essentially, we're denying everything. So let's say access list. Exit out of here. Say access list 101 permit IP any. Whoops. Any. Okay, so let's say config T do show run section access. So now what we're going to do is we're going to say, look, I want you to deny this, but permit any. Do clear IP route star. Do show IP route. Because remember, at the end of this ACL, we said deny, right? At the end of it was a deny everything else, right? So that's why. Do show IP route RIP. And what we should see is we should see that we did our job. So we have a 10.24.35/24, but only from router 3. We still have all the rest of the routes coming in from router 2. We haven't blocked any of those. We've only blocked that one prefix from this specific source. So that's how we would use an extended ACL. The source becomes where is this route coming from. The destination becomes the prefix we're actually going to allow or deny. Okay, so that's one way that we would do this. So let's say no access list 101, do show run section RIP, and I want to finish this off with a prefix list. And router RIP, and we'll say no dist list 101. Okay, now let's mess around with a prefix list and specifically the gateway option. Okay, so here's what I want to do. I want to create a distribute list that's only going to filter, essentially using the gateway option, filter routes coming from router 2. So in other words, I want to permit everything from router 2, but I want to deny the routes from router 3. So let's say do show IP route RIP. And you know what? Router 3 is just a trouble router. He's just a problem. I want to deny everything that comes from him, but I want to permit everything else. So here's what we're going to do. So we'll say router RIP, and I'm going to say distribute list. And if I hit the question mark here, it gives me a prefix list. So I'm going to say prefix, and then it asks me for the name. What's the name of my prefix? And we'll call it RIP_filter. And now what I want to do is, rather than giving it a direction, I want to say, look, anything that comes from this gateway. Okay, now the gateway, if I question mark this here, if I say, look, this is the word, so this is the name of the prefix list. So here I'm going to need 2 prefix lists. Okay, I'm going to need one that essentially matches the gateway. Where is it coming from? And what do I want to filter? So here's my prefix list for filtering. Here's my gateway prefix that essentially says where is it coming from. And in my case here, I'm going to go ahead and say in the inbound direction, because I want to block anything that comes from router 3. Okay, so I'm going to say, look, block any prefix or permit any prefix as long as it doesn't come from router 3. That's what we're going to do. Permit any prefix as long as it doesn't come from router 3. Okay, so let's say IP prefix list, and we're going to name this guy RIP filter. Now, again, what I was saying before, you can give this guy any sequence. You can say 5, you can say 10. Before I did the traditional 5, 10, 15 here, we'll just do 1, right? And I'm going to say, look, I want to permit anything. I want to say any route that's essentially zeros all the way across that's less than 32. So I'm going to permit everything, okay? Now, this is my actual filter. So I'm going to permit everything, okay? But remember, I'm going to permit it, and that the gateway prefix list is essentially going to say only allow it from one source or deny it from another source, etc. The gateway prefix list is what's actually going to perform the filtering in this particular case. And you guys need to play around with a lot of the different options. I mean, we could easily go into, an hour video just playing around with the different options here. But I'm showing you how to do it so that you guys can mess around in your lab and actually watch this happen. It's actually a lot of fun. So I'm going to say gateway, and actually before I make a typo, let me actually just take this so that I don't make a mistake, because these are case sensitive. If I say gateway here and I forget the E and I spell it right here, it's not going to work. It is going to be case sensitive. So we'll say gateway, and I'm going to say sequence 1. And what I want to do is, the first thing I'm going to do is say deny. So what host am I going to deny this from? Well, 10.1.3.3/32. This is the host address from where router 1 should be expecting the updates to come from. If we take a look here, that's the next hop address from router 3. So we want to block that, but we're going to do a /32. You could do a subnet here. Maybe you have a subnet that you want to deny RIP updates from. Maybe for some reason you're receiving some bad updates from a particular subnet, multiple devices on a subnet, you want to block them all. By all means, add the subnet. Next thing I'm going to do, though, is I'm going to go ahead and add my permit statement. We're going to say sequence 2, and I'm going to say, look, allow this from anybody else in the world. I don't care who it is. All right, so let's say do show run, section prefix, and I'm basically saying, look, I want you to deny any update that comes from router 3, but permit any update from anybody else on planet Earth. Don't really care. And I want you to permit all of these routes. Now, if I take a look at my RIP configuration, I'm going to filter based on that. So what's my filter say? Allow everything based on what this guy says. So deny router 3, allow everybody else. Do clear IP route star. Do show IP route RIP. And what we should see is that all of the updates from router 3 have disappeared, and now at this point we only have updates coming in from router 2. So these are the different ways that you can use these distribute lists to filter in RIP. You need to play around with them and be comfortable with them, and remember that the key to all of this is subnetting. If you don't know how to subnet, you're going to be completely lost when it comes to doing this. So make sure that you have a very clear understanding of how to subnet. The rest of this will just fall into place. See you guys in the next one.